I welcome you all again to this session of physics. I'm Dr. Simon Bhatnagar. I'm a faculty at Prepaze. So this is the third lecture in series of the chapter forces. So let's start that. Before starting, I'll just like you to introduce to Prepaze. So basically, Prepaze is an online platform where there are a lot of experts like me in different subjects. So you can get knowledge, clear your doubts in your home itself. Okay, you don't have to go anywhere else. Do check their website and book a free trial class. All right. So let's start topic. So forces which we were doing. So let us continue on that only. So I explain you different type of forces and also we discuss Newton's laws of motion. Okay. Now today mostly we will discussing questions only. So let me give you very basic and very important question which will help you to clarify the doubt or any concept related to the Newton's law, second law especially, because mostly the numericals are based on the second law and also the friction. Both the concepts will be combined in this question. Let us see this question now. So the question is something like this. There is a block on a rough surface. So this is a surface and there's a block of let's say 5 kg which is kept. Now for this surface, basically the mu s value is let's say 0.8 and mu k value it is 0.4. I told you mu s is greater than mu k always. Static friction is more than the kinetic friction. All right. So on this block, basically suppose let's say there is a force applied. So I will give you the value of force and then you have to do different questions related to that. Okay. Suppose this force is equal to let's say of 10 newtons. A force of 10 newton is applied on this block which is initially kept at rest, not moving. So the first part of the question, will the block move? If yes, what is the acceleration? And also find also what will be the friction acting? What type of friction first of all? So what type of friction? We have two types, static and kinetic. So what type of friction is there? Friction acting and its magnitude. And its magnitude. What is the magnitude of the friction force which is acting? All right. Now let me, if you know the like how to proceed, please do it. Then pause that video and then check the answer later on. So I will explain you how to proceed with such questions. Okay. Whenever an object is kept at rest and and a force is applied, the first thing which you need to check always. So step number one in this is find Fs max. That is the maximum value of static friction. I told you last class also in the last session that if the force applied is less than this Fs max, then the block will not move. First thing is the first job is to find out the Fs max. Let us see what we are getting over here. So Fs max, as I told you, is equal to mu s into n. What is mu s? It is 0.8. What is n over here? Now, let me draw the free body diagram first of the block. So we have a normal reaction force upward. This is an mg downwards. There is a force applied F and there is a friction force F acting backwards. So we have mu s into n. Now what is n? N is equals to now mg, right? N is equals to mg. Why? Because there is no vertical motion of the block. So n will be equal to mg in this case. All right. So m we have is 4. Sorry, I gave 5. G value, you can take it 10 for this question for the convenience, 10 meter per second square. It is 10, let's say. So what is Fs max we are getting? Fs max we are getting as, this is what, 840 newtons, right? 40 newtons. So Fs max is 40 newton. And what is the force applied? It is only 10 newtons. Will the block be able to move? No, the block will not move. The block will not move because the friction force is quite high compared to the force. The block will not move. Now, what is this? What type of friction is acting? It is static friction is acting. What is its magnitude? A lot of students make a mistake. They write 40. It is not 40 because now the block is not moving. So obviously F has to be equal to F only, right? Then only the block will be at equilibrium. If you make the small f greater than F, if you write 40 newtons, you are saying that the block is moving in backward direction. That's not possible, right? So F will be equal to F. So it's static friction and the value of static friction Fs right now it is only 10 newtons. Clear on this? So that was the first part of the question. The second part is basically BK. Now if F now it is 50 newtons, suppose. Then again find the acceleration and type of friction. What is friction acting? its magnitude, the information we have to provide. So now F is 50 newtons. Okay, obviously what would have done if the 50 newton force was given, find the Fs max, obviously, and it will be 40 newtons. So you know now that the force applied is greater than Fs max. So the force applied is greater than Fs max. It implies what? Block will move. So block will move in this case. Alright, because force applied is greater than Fs max. Now, what is F over here? It is 50 newtons. So since the block is moving, what type of friction is acting? Since block will move implies kinetic friction will act now. Kinetic friction will act. And I told you kinetic friction have a fixed value Fk of mu k into n. It is fixed. So what is mu k? It is 0.4 into 5 into 10, which makes it 20 newtons. So when I'm writing the equation of motion, so what I have to write, F net on the block, it is a force applied minus Fk. That is the net force. Now, according to Newton's second law, what is the net force equals to? It is equals to m into a. All right. So F is what? F is equal to 50 newtons minus Fk is 20 newtons. What is m? M is mass, which is 5 over a. So this is 30 by 5. It is 6 meter per second. So acceleration is 6 meter per second square in a forward direction. So that is basically the acceleration of it. So this question is very conceptual. Not every student will get it. So try to understand from it and take knowledge like what are the things steps needed to proceed, because this is the basic questions. The question will be more difficult when we are discussing the inclined planes. All right, that was the first part of that. Now let's move forward, and so there is another type of problem which is basically called pulley problems, pulley examples. It's like this. So we have suppose a block of like kept like this and over here and goes like this. Initially it is no friction, it is frictionless, right? This mass is, let's say it is let me take a value 5 kg. This mass is, it is, let me take a value, it is 1 kg. Okay, this is like system is over there hanging. Okay, now what is happening? Obviously since there's string, there's a tension force. So now there is 1 kg, this is 5 kg. So obviously this system will go down. Why it will go down? Because there is a frictionless surface. It will not, even if this mass hanging over it, it is in grams. Okay, it is 1 or 2 grams only. Even then it will go down. Why? Because even a slight bit of force on the 5 kg will take it to move in a forward direction because it's a frictionless surface. All right. So let me just do it. So A is basically like this and A is like this in this case. So when I'm writing equation of motion for the 1 kg, again draw the free body diagram. If you're doing these questions for the first time, very importantly, please draw the free body diagram. So for the 1 kg block, if I draw the free body diagram, it will be what? Mg is acting downwards. There is a tension force upwards. All right. So I will write the equation of motion as mg minus t equals to ma. M is 1. G is, let's say, 10. So it is basically 10 minus t is equals to a. Okay. For the 5 kg one, what is happening? For the 5 kg one, this is a tension T, and this is basically, there is no, okay, so there is no friction, so there is no backward force, there is only tension T, which is taking the block. So T is equals to what? 5 into a. Different, there is only force acting on it, right? So T is 5 a. That means what? I can compare these two equations now, and so 10 over 6, that is basically 5 by 3. 5 by 3 meter per second square will be the acceleration of the system. All right. So it is, the system is going downward with 5 by 3 meter per second square. And what is the value of tension? It is 25 by 3 newtons. That's it. All right. So this is the way we have to proceed with the questions like this of the pulley examples. And after this, basically, we have different kind of pulley problems. Like suppose, let's say this is a pulley over here, and this is a mass which is hanging. This and this and this is fixed pulley. Okay, let me call this mass is 10 kg. Then, and this is, let's say, is 5 kg only. We need to find out the tension force on this and with what acceleration the system is going down. Now the pulley is 1, so obviously this will go down with acceleration A. This will go up with an acceleration A because it's the same string, right? So the tension will be same and the acceleration will be same. Now for the 10 kg block, again, draw the free body diagram. So when you draw it, it will be like this. So it is mg, which is downwards, minus the tension force, it is equal to 10A. All right. For the 5 kg one, how will you write? Tension is upward because it is going upward. So the net force has to be upward direction. That's why T minus mg, not mg minus T. for the 5 kg. So T minus mg, which is 50, and the 5a. So from this, we have two equations, two variables. So what we can get from here is that 100 minus 10a is equals to 50 plus 5a. That is basically, if we do it, 50 equals to 15a. So a is what? 510, 3s are, that is meter per second square. That is 10 by 3 meter per second square. And what is the tension force? 550 by 3 plus 50. You can put it over here in this equation. So it will be equal to 200 by 3. 200 by 3 newtons. And that is how we call the tension force. Alright, so this is the way how we proceed for the questions of related to the when we have two pulleys together. Alright, now so these are the different various right now there are a lot of examples okay to be discussed. So in the next session, basically what I will do, I will include the inclined plane problem. So with inclined plane problems, and then we will have elevator problem. That's it. But there is a lot more and more complicated questions which can be asked. So obviously we are not going to do that in the regular session, in this sessions, these are sessions. For more practice and to get more deep knowledge of what we did and to clarify all your doubts, I will suggest please book a free trial class. Go to Prepaze, book a free trial class. And if you like the teacher, whichever teacher you want, you can continue the classes with them. Also, you can change the teacher. I will see you in the next session of ours of the forces. We will discuss few more example, and then the forces chapter will be finished after that. And so that's it for today. So see you in the next session. All right. See you. Bye.